All right, today we are going to continue with our topic of limits, and we are going to look at algebraic limits today. So we're going to spend the next couple videos actually looking at algebraic limits and evaluating them algebraically. Very simply, the very first couple, I just want you to see that these are simple ones. Here we are taking the limit as x approaches 3 of x squared. And hopefully you could sort of guess that that really means what do we think the approximate value of the function is as x approaches 3. And so it would be 3 squared, which is 9, meaning the point on the function, right, is 3 comma 9 is the y value. So these are limits by what we call substitution, really simply, and as soon as you actually take the limit, you will notice that we don't write the word lim anymore. We don't write the limit anymore. So pause the video really quickly and do the second one, please. Okay, and there you go. You should have gotten an answer of root 2. So very simply, to evaluate a limit algebraically, you simply sub in the value for x and you evaluate. As long as the function is continuous at that value of x, in other words, and we'll talk more about that as time goes on, then the limit will simply equal the value of the function. Okay, so the y value. So the question becomes, what do we do when the function is not continuous? When it's a piecewise function and we sort of have a jump in that function or that sort of thing. So let's take a look at what happens with this one. If we try to do substitution, we get 9 minus 3 squared over 3 minus 3, and of course if you evaluate that you will see that we get 0 over 0, and I'm going to put that in quotations because that's not actually our answer. Okay, this is called an indeterminate form. There are many other types of indeterminate forms, but for our purposes right here, this basically means that we can't evaluate this limit by substitution, and we must try other methods. And today we're going to talk about those other methods. Okay, so today we're going to focus on the other methods, as I said. The first one is factoring, the second method that we'll look at is rationalizing, and the third method is simplifying. Okay, so quick look at our first question here, and hopefully you can see that if you did substitute negative 3 over 2 into this limit, you should always check for substitution first. I hope that you can see that you get this 0 over 0, which we call an indeterminate form. And so that means that we're going to have to try another method, and hopefully you can see right away from the top that we are going to take a look at the method of factoring. Okay, so I want you to pause the video and I want you to go ahead and factor the top. Okay, so a couple of notes as you're looking at my solution and writing out your own solution at the same time. Here, we're still writing this limit at the front. Yes, you need to for proper form and proper notation, and I hope you agree that this is the sum of cubes that you get on the top. So now you'll note, of course, the most important and the key step is that what we call sort of this problem piece of 2x plus 3 on both the top and the bottom now cancel out, and you are simply left with taking the limit as x approaches negative 3 over 2 of 4x squared minus 6x plus 9, which I think you could see that you definitely don't get 0 over 0, and so we now turn to substitution. So you now literally take the limit by substitution. We no longer write the limit at this point. We go straight to substitution, and you're going to need to do a little bit of fraction work here. We're going to do 4 times negative 3 over 2 squared minus 6 times negative 3 over 2 plus 9, and you're going to need to go ahead and evaluate that. So again, always pause the video, make sure you can do that part on your own and fill it in, and you should get an answer of 27 there. Okay? Let's try another one. So take a look at B. Hopefully your first instinct is to factor here. It might be to expand this top right here. We did take a look at this briefly in advanced functions at the very beginning of the year, but I do really want you to see that as a difference of squares factoring, okay? You do need to do it that way, so let's factor the top. If you recall, this is a difference of squares, so our first piece is 2x minus 3 in both brackets. And then the square root of 9 is minus 3, and we have a plus 3. Okay, so I do want you to see those as difference of squares, and you want to make sure that you are not expanding. So when you see the note in my outline that says don't expand, that means I want you to see them as difference of squares or sum or difference of cubes. So now let's simplify those brackets and see what happens. So we have the limit as x approaches 3. The one bracket becomes 2x minus 6. The other bracket becomes just 2x. All over x minus 3. And good for you if you can now see sort of where this is going. The top, the first bracket right there, you can pull a 2 out of that. And aha, why is that good? Maybe you can see why that is good. Because now this problem piece of x minus 3 now cancels out. And so now we are allowed to take the limit by substitution because we don't get 0 over 0 anymore. So remember, now we just simply plug it in. We have a 2, and we have a 2 times a 3. Okay, and again, hopefully you can see that on your own, that we end up with 12. Method 2, rationalizing. I think you can see from the question that when you do see radicals or an opportunity, we are going to take that chance, and this is where we are going to do rationalizing. Okay, and hopefully you recall from grade 11 that rationalizing this limit means taking and multiplying by the conjugate. Now, I don't want you to think of it as always the denominator, because it is possible that you would have to rationalize both the numerator and denominator, or just the numerator or just the denominator. So does everybody know what we mean by the conjugate in this case? The conjugate of the top is root 1 plus 4x plus root 1 plus x. And of course, in order to multiply that, I have to multiply both the top and the bottom by that. So that really I'm just multiplying by 1. And then I need to do a little bit of simplifying, okay? So note on simplifying here, you are going to expand out the top. You're going to FOIL it out. You're doing this for a reason because it ends up really nice. But then the bottom, the piece that you're not actually rationalizing, you're just going to write it the way it is. Don't actually FOIL it out, okay? So pause your video for a minute and then have a look at what this looks like. Okay, so on the bottom, this is what I mean by not expanding it out, just writing it exactly the way it looks beside each other. On the top, when we FOIL it out, when I take this piece and I multiply it by that piece, I simply get 1 plus 4x. Okay, when I'm doing my FOIL, my O and my I, my outside and my inside, end up canceling each other out. And then when I do the lasts multiplied by each other, I have a minus, and in brackets, I have a 1 plus x. And then we're going to go ahead and we're going to simplify this. Okay, and hopefully you can see on the top that you do just end up with 3x on the top. On the bottom, we leave it exactly the way it is. And if you look back to the very top of the question, I didn't actually have you check that you get 0 over 0, and I should have had you do that right from the beginning. Okay, by pure substitution right at the beginning, we get 0 over 0. That's how we know that we need to rationalize. So now if you take a look at what we have at this point, you now see that it was the x on the bottom that really was the problem that was causing the indeterminate form. And so now we have an x on the top and an x on the bottom, and so they cancel out. And just like with factoring, the problem piece, as we like to call it, is canceled out. And so we are now left with simply the limit as x approaches 0 of 3 over this giant thing. And no longer will we get 0 over 0 by substitution, so we now actually substitute. This limit piece goes away, and we simply plug in 0. So we have the square root of 1 plus 0 plus the square root of 1 plus 0, and we end up with 3 over 2. Okay, so this process of rationalizing is going to take a little bit of practice, but if you follow this example, by the time you've done it a few times, you should be okay. And for our last one, okay, fractions within fractions, as you can see. Okay, right away, check by substitution. If I put 4 in for all the x's, I end up with 1 over 9 minus 1 over 9, and I get 0 on the bottom, and so I get 0 over 0. Okay, so here our method is simplifying, and that's just really getting rid of the fractions within fractions. So as I've been saying all along, anytime you have fractions within fractions, okay, let's write it out properly so you can see what you have. You have 1 over x plus 5 minus 2, and I'm going to go ahead and I am going to simplify that one right away. You notice you can factor out a 3, and then you have an x plus 2. It doesn't really matter. It's just a good thing to do right there. And that's divided by 4 minus x. Okay, so we never want fractions within fractions. And if I asked you right now to guess what you were going to do you have a guess? Hopefully you have a guess. Anytime you have something that looks like that, you're going to want to make a common denominator and do the best simplifying that you can. So again, please pause the video and try to make that common denominator on your own, and then restart and see if you got it correct. How'd you do? Okay, and again, in terms of simplifying, we are going to simplify only the top here, and hopefully good things will happen. Problem piece is, of course, this guy, so we are looking for that to cancel out in some way. So go ahead and simplify the top and see if you can get to the same place as me. The other thing I forgot to mention is note, I have changed this divide to times and 1 over. Okay, so again, this is how I like to write it to make sure that I've done it correctly. Okay, and magically that top simplifies to x minus 4. Not exactly the same as this, but remember that this one over here can be written as negative and then x minus 4. And so they are the same, they're just different by a factor of -1. So instead of canceling out and being 1, they cancel out and be -1. And so there goes our problem piece, and we are simply left with the limit as x approaches 4 of -1 on the top, and on the bottom we have an x plus 5, we have a 3, we have an x plus 2, and we are simply ready to substitute now. Okay, once we substitute, we get rid of the word limit, and we can go ahead and plug 4 in for all the x's. And you should end up with -1 over 162. Okay, again, this is definitely going to take practice, and I want you to spend today and even part of tomorrow working on this and practicing these skills. Thank you.